Thank you for that very kind introduction. So thank you also very much for inviting me. It's honestly a very, very great honor for me to be here today with you. I will talk about and address the emerging opportunities, but also the emerging challenges and risks coming from the digital transformation of the agriculture sector. I will draw conclusions for agriculture policy, and I also will draw conclusions for our profession as agriculture economists. But before I jump into digitalization, let me summarize my take on the grand challenges of the agriculture and food sector in a few bullets. First of all, the sector needs to deliver more. So we need to meet an increasing demand for food worldwide, and especially we also increasingly need to meet the demand for ecosystem services that the agriculture sector shall provide, whether this is biodiversity or climate change mitigation, carbon sequestration. However, in the same moment in time, we see that the production potential to deliver is actually in decline because of climate change, because of soil degradation, and this has implications. So delivering the same amount of private and public good is increasingly becoming more difficult and is increasingly becoming more costly. Moreover, the agriculture sector faces increasing resilience challenges like extreme weather events. And finally, the sector at large lacks sustainability almost in every dimension, notably environmental dimensions like biodiversity loss, but also pollution. Also in other domains like social sustainability. And against that background, there were various ambitious policy goals formulated in that field, notably in Europe, of course, the Farm to Fork strategy, aiming to transform the agriculture sector by 2030. On a global level, the Global Biodiversity Framework, the SDGs, the question is how to come there. In short, our sector needs to deliver more in the future with a massively smaller footprint despite reduced resources available. And I'm fully aware that this is not only on the agriculture sector alone. That needs to be the food sector at large. But as said, I will focus on the agricultural sector and systems here in my talk. At the same moment where we see these kind of challenges ramping up, we also see that our agricultural systems are transforming rapidly due to digitalization, and it's sometimes called the fourth agricultural revolution that we currently undergo. So this is massively changing the way we do agriculture. And agriculture and digitalization is not a specific technology, but it's basically a set of a very large range of very heterogeneous but interconnected technologies, applications, and tools. And I will give a very simplified structure to this set of technologies, just to also guide my talk later on. At the very core of these digital technologies are very often in agriculture georeferencing and location technologies, but also diagnostic tools, tools that allow to monitor and gather data from agriculture systems and individual units. Might it be a field, might it be an animal or an entire farm? And how to use diagnostic tools might operate at very different scales, ranging from a handheld sensor to a nitrogen sensor mounted on a tractor to a satellite being in space. But these technologies alone are not at all sufficient to actually untap the big potential of this digitalization. In contrast, we need to make use of what we collect and bring that into action. And one very good example are what I call applicative tools. Tools that basically make use of the information collected, provide farmers with an information that he or she can adjust and improve her decision making. Precision farming being a good example here. But here, so we use digital information to make our decisions better, but we can even go one step further and let, so to say, the new technologies taking over making the decisions. And then we have a dimension that is here called automatized and autonomous processes, machinery, and farming systems. So here the decisions are made by an algorithm, for example, an autonomous robot running over the field. But digital technologies and innovation is not only something that you see in the field as a machine or something like that. Far in contrast, the big gains are potentially even somewhere else in new data platforms, but also in new networks, information, and communication channels. So, for example, digitalization enables that farmers can much better connect to their animals, to their field, to their machinery, but they can also connect much better and easier to other farmers, to administration, to also the consumers in the end. And my talk will end with the conclusion that all these technologies, if combined in the right way and if governed in a good way, have the potential to make our agriculture systems more sustainable and more resilient. In order to illustrate the point with the sustainability, I will use a framework along the gradient of efficiency, substitution, and redesign. And I will briefly introduce these concepts in a minute and also give always technologies what I actually mean with that. Efficiency is nothing else than cutting away waste and picking the low-hanging fruits. And our current agriculture systems are full of opportunities to cut away waste. What I mean with that, just reduce our input use, but still produce the same amount of output. And this is easily possible. And digital technologies are one way to facilitate that process. And here are two examples. One are guidance systems or automatic steering systems that basically allow to avoid inefficient and redundant operations traffic on the field. And this just saves fuel, saves inputs. So straightforward, now nobody is hurt by doing that. The same holds for variable rate technologies that are displayed on the right. So variable rate application of inputs like seed, fertilizer, pesticides, even water. So basically the farmer receives based on a combination of different information collected by sensors, a prescription map where to apply inputs and where not. And in the end, farmers save money, the yield is the same, and the important point, there is an excess of inputs not lost to the environment. So this is a sustainability improvement. So there is a big potential contribution in making agriculture more efficient. But beyond reducing the harmful inputs that we use in our systems, we also have to ask, like, where can we substitute away fully from them and get rid of some of the inputs in specific systems? And this is substitution. And digital technologies also have the potential to facilitate that substitution process away from the harmful inputs. An example here is a weeding robot that identifies weed in the field, removes them mechanically, and with that replaces the use of herbicides fully. If this is an autonomous weeding robot, it's maybe even replacing the labor resources that might be used in that field. To the right, you see how digital tools, very simple one, can enable a massive switch from chemical to biological pest control systems. This, what you see there, is the major way how the corn borer, the European corn borer, is controlled in Switzerland. This is a drone-based application of Trichogramma, a parasitoid wasp, so that replaces the use of insecticides to control that corn borer. So there's a large potential of kind of digital technologies to make agriculture more efficient and also to substitute away from the critical inputs. But efficiency and substitution have one major problem. They only address the problem and they do not address the cause of the problem that is underlying. So the pest is still there that we have to control, and this is the issue that we actually should tackle. And this is the question of fundamental redesign of agriculture systems, getting rid of the problems by making our agriculture systems fundamentally different. And digital technologies do have the potential to support also that transition. Obviously, that is nothing that you can buy in the shop next door right now, but this should be a long-term vision. There are many examples how to do that. One entry point is changing our landscapes. Making landscapes more diverse is a fundamental entry point towards more sustainability. For example, because more diversified landscapes reduce the pest pressure, and with that reduce the need to have an intervention with pesticides. And digital technologies can guide that process. So in principle, what we want to see is that the large farms operate a bit like the small farms again, but in a very efficient way. And digital technologies can provide that pathway. This picture is from the patch crop project at the south in Germany, a very nice example showcasing the potential, but potentially also the limitations. Another example might be digital twins, so digital representations of a real-world object, an agricultural system, a unit therein, an animal, a field that basically allows the farmer to predict and forecast, also problems that emerge, a pest that emerges, a disease that breaks out, and also allows with that early intervention before the problem actually happens, so that you can avoid that you have to apply pesticides or apply antibiotics. So obviously these are more forward-looking things, but fundamentally very interesting to think about how agriculture systems are in the future. So efficiency and substitution and redesign are important elements. Now in like the practical world outside, you basically, or also in the scientific world, you have two spheres. One says, okay, we need to do what we can do right now, efficiency and substitutions, and other basically neglect that potential because it's shallow sustainability, it's incremental in itself, and only focus on redesign. And we should focus all our resources on using digital tools for redesigning. But I believe we need all of them together because, as said, efficiency and substitution, often the tools are already there and could be used to meet our short-term policy goals. But fundamentally, we shouldn't forget about the long-term vision of redesigning. So combining these three elements together might be a very good way forward. Until now, I've talked about how we can make our production more sustainable using digital tools. But already right now and much more in the future, our farmers are not only making money by producing food and selling food, but they also earn an income by generating ecosystem services. Yesterday we talked about the carbon issue. There are many programs on biodiversity that gives incentives for farmers to produce biodiversity. And also along that trajectory towards conservation in general, digital technologies provide ample opportunities. A straightforward example for that is the concept of precision conservation. Everything that I said before, using the digital information, giving prescription maps, is turned into a question not of how to do things to produce better, but to conserve better. Giving farmers an indication, a prescription map, what to do where in the field, that the ecosystem services we targeted, like carbon sequestration, biodiversity, are achieved in the best possible way for the environment, taking into account the opportunity cost for the farmer, for example, taking into account the yield potential across over your entire farm. So there are very good entry points that digital innovations can also facilitate conservation. Beyond sustainability and conservation, I believe that these digital innovations also have a role to play to make our agriculture systems and our farms more resilient. More resilient, that means giving them a higher capacity to withstand shocks and challenges. And this shall go beyond like a very short-term resilience in the terms of robustness, for example, the ability to stabilize a yield despite the fact that you face an extreme weather event, but shall go beyond that, including, for example, an adaptive capacity of the farm to adjust the resources, adjust risk management to withstand some of these shocks, but also shall include a transformative capacity of the farm to basically fully switch away from what he or she is doing now into something that is less vulnerable. So if a farm has the opportunity to switch from dairy to crop production and vice versa, this is an asset because he or she, the farmer, can escape from a specific risk. And I believe that also digital technologies will play a role in increasing the resilience of our farms and farming systems. For example, in the context of extreme weather events, there are many nice solutions already on the market and probably much better ones in the pipeline, giving farmers access to early warning systems, but also information how to cope with an extreme weather event, giving them the opportunity to, in the short run, protect their yields and protect their profits. Digital innovations are also enlarging the scope of risk management for farmers substantially. One example are remote sensing technologies that enable to develop new and better insurance solutions that are more efficient, and they are also more inclusive because they reach more farms, they reach more farm types. And having just a broader pool of risk management tools in the toolbox is increasing the resilience of our agriculture systems. But digital technologies also have the potential to increase the transformative capacity of the farms, especially looking at solutions like digital advisory extension services that are emerging that might be an opportunity to bring farmers the information what could be an alternative and how could you reach that alternative. And just having that capacity gives farm more resilience in the sense of transformative capacity in the long run. So now, to sum up until here, the very positive picture, digitalization has a large potential if used in the right way to make agriculture more sustainable, contribute to conservation, and make it more resilient. In addition, there are even economic opportunities for farms. We talked about better risk management, saving variable costs is an asset, obviously, substituting away from potentially scarce resources in the future, like labor is an asset, but also tapping on potentially new market, like providing ecosystem services. These are opportunities for the farm. However, any use of these digital innovations will be costly and often requires investment in machinery, in software, but most importantly also in knowledge that farmers have to build up, and any investment in that will also involve risk. And currently, I would claim that the economic viability, so comparing risk and potential benefits for the farm itself, is often limited, and with that also the adoption. Despite the fact that I'm fully aware that there is a GPS in almost every machine and there are so many sensors and so on, but the higher levels of the digital innovations that I've shown, applicative tool, autonomous processes, all these networks, they are currently not used to a very large extent in European agriculture. It doesn't hold globally. So we see the more complex technologies are adopted less, but these are the technologies with the highest potential for sustainability and resilience. And we also see that the uptake differs across farms and farm types. So a larger farm with better education, being richer, younger, in a region where you have a good digital infrastructure is obviously more likely to use many of these technologies. And to illustrate that point with the farm size and why it matters, I want to make that example on variable rate fertilization. So imagine you can cut away your fertilizer use by 20% and you still have the same yield. That's fantastic. Huh? But what does this mean for a farm with 15 or 20 hectares of arable land? Like in Europe, that's very common. This is just a few €100 per year. And for a few €100 per year, nobody's going to invest in new technologies and new knowledge. So this is a limitation that we will talk about in a second too. And there are further risks and challenges. So what I described is ultimately a digital divide. So some farmers use and some farmers potentially can benefit from digital innovations, others not. So we have a digital divide. And if we push further for digitalization from an industry perspective, because, for example, the industry wants farmers to be more sustainable, to be farmers more transparent, and also from a governmental perspective, because we want to push that, then we might lose some farmers. And with that, we may accelerate structural change. We will potentially with that decrease the diversity of farms and farming systems that we have. And I believe that the diversity of European agriculture, also in terms of farm size and what farms do, is an asset. And losing that would be would come with very high cost. Furthermore, we see that the process of digital transformation also comes with a kind of like challenge on the up and downstream sector. So having machinery, pulling that together, but even more having the platforms that bring it all together and having the hands on the data potentially increases power. Power in the hand of a few companies. And I'm not saying that the companies are bad, but if they have too much power, this goes on the expense of the society at large and farmers. So also here, potentially, some diversity is probably quite good. There are also very fundamental questions. What is the farmer of the future? If AI is running half of your farm, what actually is a farmer then? And what is the skill set of a farmer that we need for the future? And these are far from trivial questions, obviously not only agriculture, economic related questions, but we need to address these questions. The technologies on their own also come with a lot of uncertainties and risks. So I described very nice outcomes of the technologies, but very often, to be honest, they are still uncertain because the technologies are not there or not yet on the market. So there's a large uncertainty in which we operate, and this is important for farmers, of course, but also for policymakers and other stakeholders, how to deal with that uncertainty. Digital technologies also bring fundamentally new risks and challenges. So if we rely on algorithms, if we rely on networks and everything being connected, well, we also run the risk that we have new systemic risk like emerging from algorithmic biases or network vulnerabilities. We also have new problems of responsibility and accountability. So imagine there's an automated process basically leading to application of a pesticide where it shouldn't be. Who is accountable? Is it then the farmer? Is it the hardware provider? Is it the software provider? And solving some of these fundamental questions will be very important to get technologies actually being used. And the same holds for questions of data ownership and management. So here we are against a background where we see potentially large opportunities. We see a lack of economic viability, and we see a lot of risk and challenges, and that somehow calls for the role of policy and to discuss the role of policy in that context. And agriculture policy in the era of digitalization, for me, has two sides of the medal. The first one is that digitalization, the process, this transformation implies new agricultural policy changes or challenges itself. For example, because totally new policy fields emerged that haven't been there before. So you have to regulate how an autonomous robot is actually being allowed to operate on a field. That wasn't there before, and the same holds for some of the data-related policies. But digital tools also allow to develop fundamentally new and often also better agricultural policy designs and instruments. For example, take remote sensing that allows to monitor much better what farms are actually doing. We couldn't see that before. But even beyond, remote sensing and other sensors might allow to measure the outcomes of agricultural production much better. Yesterday, Marion showed that plot with the greenhouse gas emissions measured by a satellite. There are many more things that will be in the future we are able to measure using digital tools. Maybe not with the perfect data quality, but we can measure it. And we can use that information to basically develop new policy instruments, for example, result-based payment schemes, because we actually can now measure the outcomes. So this is fundamentally changing agriculture policy. And the second side of the medal is that digitalization can be used by agriculture policy to reach its goals, like producing food, increasing biodiversity, reducing greenhouse gas emissions more efficiently, and avoiding the risk and inequalities I talked about. And let me be clear, the digital transformation of the agricultural sector is happening anyway. So this is not a fundamental question that a policymaker can ask, well, do we want it or do we want it not? Now, we have to ask the question, how can we steer that process into a direction that it's useful for us? And an important entry point for me, at least, is that these technologies with the highest potential societal benefits are least adopted. There's this mismatch of private and public benefits, and that can rationalize policy intervention. But having that said, digital innovations should not be a policy purpose on its own. So there shouldn't be a policy goal to have as much technology out on the farms. In contrast, the focus shall be only on achieving the overarching policy goals. And if the way is a digital technology to use that most efficiently, well, then do that. And if not, don't do it. Another important element for policy is I talked about the uncertainty that is related to the technologies. And in addition, we also are operating in a system that is highly dynamic. So you see this quote here, in the world of precision agriculture, each new growing season seems to bring a fresh batch of brand new technologies. And beyond precision farming that holds, so a digital technology that might be very useful today probably isn't in 3 years. So focusing on individual technologies, on individual applications is probably misleading. So we rather shall create an enabling environment, shall put out incentives that those strategies that are most cost efficient to reach our goals are actually developed. We should incentivize efficiency, substitution, but also redesign on conservation in the long run. and how to create an enabling environment for digital technologies to be used in the right way, obviously is a very big question, and I have not the entire answer, but I believe a fundamental cornerstone shall be infrastructures. Infrastructures in terms of technology, access to high-speed internet, a good data infrastructure that farmers can rely on, that is maybe in public and not on private hands, a good legislation and regulation process that just removes some of the uncertainties, but also education. And of course, also economic instruments have a role to play. Remember that example that I gave with cutting away the 20% of the fertilizer and this not paying off? This is partly also due to the fact that the inputs like fertilizer and pesticides are simply too cheap. The external costs are not included in the price of these inputs, so raising the price of fertilizer, pesticides, and other harmful inputs will automatically make farmers seek for options how to reduce the use of these inputs and make also these tools more attractive. And the last point on the policy is we shall have a kind of like a paradigm shift and go away from single focus application and also go away from single farms. Small farms will never be the place where investment in all technologies takes place, and it also shouldn't. And also probably not every farmer should start now a Python coding course. In contrast, we really should set out an environment where farmers can cooperate and use machinery jointly and use solutions jointly, but also the role of contractors that do provide services to the farms, digital technology services to the farms will increase. So digitalization and that transformation process has implications for agriculture policy, but I believe it also has implications for agriculture economic research. First of all, there are many interesting research fields that can and shall be addressed. Obviously, decisions taken by all the actors in the agri-food sector with respect to digital innovations is an important element, and we can do that. We can also provide evidence on public and private cost of digital innovations and the risks that are involved. And I think especially an important point in the future is going to be if we move away from the early adoption phase into more widespread adoption and diffusion processes, and what happens on the large scales, what are the feedback mechanisms, what are the rebound effects involved in using more digital technologies. This is going to be an important asset too. I believe agriculture economics can and shall also become more relevant for other fields. I don't know what your experience is, but very often agriculture economists are asked to make a cost-benefit analysis after a technology was developed. And it shouldn't be that way, but we also have the opportunity to identify what are the fields of high economic opportunities, of high policy needs, and provide that to other disciplines. That ultimately calls for interdisciplinary research, bringing together multi-disciplines. But also, I think we need more transdisciplinary research in that field, actually involving those that are affected, the farmers, the advisors, the policymakers, the industry. And finally, that digital transformation not only has implications for what we work on, but also how we work. And for me, the most striking example is that our discipline is moving from a discipline being facing data scarcity to a discipline that will be overwhelmed with a massive amount of data. Just imagine we have billions of sensors around in the world measuring the state of plants, animals, fields, farms, entire value chains. And if you have access to that data, that is a very powerful tool. And this comes with a lot of opportunities, but also challenges. And that requires us as a discipline also to make use of new tools, new knowledge, new approaches, and at that conference many of them are already around, but also requires fundamentally new teaching. So let me conclude. I think if wisely used, there is an opportunity that digital technologies can make our agriculture systems more sustainable along the entire gradient of efficiency, substitution, redesign, conservation. This transformation process also has resilience implications. For example, there are tools, digital innovations that can make farms more resilient, but also new resilient challenges and risks actually emerge from that. We currently observe a lack of economic viability for the most promising applications that kind of like might call for a policy intervention, and in general that technology development process that is ongoing shall be accompanied with a really responsible governance and policies to untap the big potential benefits, potential public benefits should be used. And finally, that entire process has large implications for agriculture economic research and teaching. Thank you very much.